us about cases where innovative technology is being installed. These are really first-of-their-kind cases, and I'm sure that also this session will be very interesting.
How exciting. So actually, I'm just going to start. So I am honored to introduce to you the next speaker. Everybody stand up. Sara Kralmark, project leader in business development at Kraftringen, who is one of these partners of the conference. Welcome up, Sara.
Welcome up.
So when Sara is not out camping in any weather, she is also a hobby carpenter and creates beautiful things on her spare time.
Thank you very much. It feels really good to come up here when people are cheering. Thank you. Very good idea. Hi, I'm Sara. I work with business development at the energy company Kraftringen in Lund. And I usually say that almost everything I do at work has something to do with sustainable city development. And since 2 years back, that includes being part of building the world's largest low-temperature district heating network, aiming to provide heat to over 40,000 people, and based almost exclusively on excess heat. Yeah. Thank you. When I tell my family and friends about this, I normally don't get the wow response that I think I deserve. So I'm very, very pleased to be here to talk to all of you, presumable district heating and sustainability nerds. I hope you're excited. I am. So the name of the project that I'm working in is Cool District Heating. Cool DH, that's the homepage, and also the hashtag if you want to use it. And if you think that the name Cool DH is because it is a cool, and by cool I mean awesome project, then you're right. However, you're also right if you think that it's an abbreviation for cool ways of using low-grade heat sources from cooling and surplus heat for heating of energy-efficient buildings with new low-temperature district heating LTDH solutions. It is also fine to just think of it as a really awesome project. So, but first, some information about the company that I work with, Kraftringen. Kraftringen is a municipally owned energy company headquartered in the city of Lund, which is just 20 kilometers away from where we're sitting right now, with 260,000 energy customers and a little over 500 employees. We're counted as one of the largest energy companies in Sweden. And one of the things that we do is district heating. Our third generation district heating network is just a little over 1,000 kilometers long. And it's connected to the networks in the cities of Helsingborg and Landskrona. So we've formed a joint venture with the energy companies in those cities, allowing us to really optimize the efficiency of the production. And the amount of heat that is produced and distributed in Kraftringen's part of this giant network is 1,100 gigawatt hours per year. That corresponds to about 50,000 households for you who don't are nerds like I am. We had the goal of making our district heating completely fossil-free by 2020. And we reached that goal last year in April. Yes. Yes. You're way better, though, than my family and friends on this specific topic. So, in addition to our normal, traditional district heating business, we're in the process of building the world's largest low-temperature district heating network. And this is something we do in a city district in Lund called Brunnshög. And we do it as a part of the Cool DH project, which is a project that receives funding from the European Research and Innovation Program Horizon 2020. Now, not only Sweden is a part of the LTDH project, Denmark is too. Do we have any Danes in here? Yes. Yeah, you can clap now. No. So in Sweden, we're building a network which will have a supply temperature of 65 degrees. You know why that's good? Because Britta and Sven and Kerstin told you before the break. It will be about 6.5 kilometers of pipes, and we're building it in previously undeveloped land. In Denmark, they're building a smaller network. It has a supply temperature of 55 degrees, and they're building it in an area with mainly existing buildings. This project started in October 2017, and it will continue for 4 years, so that's until 2021. And the aim is to develop, then demonstrate, then verify new and path-breaking solutions for district heating with low temperature. And of course to spread the knowledge, like I'm doing right now, to you guys, to Denmark, to Europe, and to the rest of the world, because this is very unique. We have 10 project partners in the LTDH project. In total, we have representatives from district heating production, distribution. We have the customer with us. We have the academy. We have a pipe company developing new pipes. And we have an international network for district energy. Now, before I introduce you to the Swedish part of the LTDH project, I want us to take a look at the concept of excess heat, or surplus heat, or waste heat, or residual heat. It's all the same kind of heat. Because the fact is that surplus heat and low temperature district heating, that's a very good match. So during the last 40 years, the Swedish district heating production has increased by 4 times. That's awesome, right? But at the same time, the emissions from district heating has decreased by 90%. 90%. It means that Swedish district heating companies have shifted from the black field, which is fossil fuels, to mainly green, which is biomass, and also the blue, which is some waste incineration. Kraftringen, we're in the green field, 100% fossil free. And then we have the red field in the bottom. It says excess heat. And the question is how large the potential of excess heat in Europe is. Because that can answer why the European Union wants to finance a project on low temperature district heating. That's the context of this. I will guide you through this diagram. It shows the European journey from primary energy, that's to the left for you, primary energy, for example, in the form of nuclear power, some hydropower, I guess that's Sweden, and natural gas. And then to the right, you have what we use in the end. For example, electricity, nice kind of energy. We also have quite a lot of heat. And what happens in the middle is that we convert the energy. And it just so happened to be that during the conversion processes, we get a lot of excess heat. Approximately just as much as the heat load that we use in the end. What I'm saying is that if we could just use all of the excess heat that's being produced only within the energy sector in Europe, Europe wouldn't have to produce any heat actively at all. That's a large potential, I would say. So why is the utilization so limited? Well, it's not very hard. No one's being stupid. It's because of 3 factors that all affect the economy. Time, temperature, and localization, I usually say. Time, because this kind of residual heat might, it often doesn't come when we want it. It also fluctuates a lot. It's like solar power or wind power. It's not very reliable heat sources. Localization, because it may only be available at places far away from a city district or where there is a need for heat. You need a district heating network to actually distribute it. And that's not always the case. And finally, temperature. Because very often this residual heat comes at temperature that are wrong, meaning they're too low to be used in the traditional 80 or 90 or 100 degrees traditional district heating networks. So with this background, I will now tell you about the Swedish district heating CoolDH site, which is a place where we are overcoming all of these three factors. Yeah, wow. This is a vision image. Thank you, Reto. This is a vision image of a new city district that's being built in the northeastern part of the city of Lund. In the future, we will have 40,000 people living and working in this area. For you Swedes, that's like taking the city of Trelleborg, I'm from Skåne, and putting it in the outskirts of Lund. It's quite a large city district. And the main reason for expanding Lund in this area is the ongoing construction of the International Research Facility European Spallation Source, or ESS, as you might have heard of. It is also because the already existing Swedish research facility MAX4, which is located just adjacent to ESS. For your information, yes, there is a MAX 1, 2, and 3, but they're much smaller and they're more like normal laboratories, and they're further down in the central of Lund. However, this is what Brunsvik looks like today. Yep, it consists mostly of fields, and even though they've started to build buildings down here in the southern part, it will take decades before the whole area is covered with buildings. But the municipality of Lund has set up really high goals for this area. Ideally, they want it to be self-sufficient in energy. And that's a goal they want to reach by building really energy efficient houses. Also, they want to utilize solar power. And above all, they want to use the enormous amounts of residual heat that's coming from ESS and MAX4. So let's look at MAX4. It looks pretty much like a donut. And I mean, this is an awesome research facility. No, MAX4 was built and then opened in 2016. So it's been up and running for a couple of years now. The processes inside of MAX4, where they accelerate particles, they are extremely temperature sensitive. They're also extremely energy needing. They have a large heat demand, and they create a lot of surplus heat. And this heat needs to be cooled away, right? And cooling something, that's actually exactly the same thing as taking away heat, right? And as such, we've built an energy central. Kraftringen has built an energy central from which we deliver heat, meaning that we're delivering cooling, meaning that we're taking away heat from them. And also at sometimes during the year, during winter, we supply them with some heat also, but they don't need that very often. Sorry, I've had a bit of a cold and it's not completely away yet. This is what it looks like inside MAX4. So we take care of the heat that's generated inside of MAX4 in 3 different systems. One system is for normal climate cooling inside the building, and 2 of the systems are for cooling special process equipment. And at present, so you can see the temperatures there, they're pretty low. We're not talking about 100 degrees here. No, what we're doing right now is that we're using heat pumps. So we get some heat from MAX4 and then we raise the temperature up to 80 or 90 degrees. And then we distribute it on our traditional, normal district heating network that covers Lund and goes all the way up to Helsingborg and Landskrona, right? That's happening today because this facility is already up and running. It has been since 2016. So science, it is heating the city already. However, as the new district of Brunnshög grows and establishes an increasing heating demand, we will start and gradually increase the amount of heat that instead of being raised up to 80 degrees, will get raised just a little bit, up to 65 degrees. And then it goes out to the Brunnshög area. Yes, I got it. So the picture to the left, that's inside of the Energy Central. And here to the right, I took this picture last week. This is from outside, and you can see pipes going into the Energy Central. That's our low temperature district heating network. That's the pipes going in there. Yeah, it's happening right now. This was a couple of weeks ago. We did the final thing. And you know what? We have our first delivery today. Yeah, well. In 1 hour, my colleagues will be up there at the first customer, and they will, I don't know, do switch or jump or something, but it will start flowing. So, yeah, it's amazing. What a day. We can't say exactly how much heat we will get from Max4 in the future, because they're waiting to get financing to do things inside the facility. But we believe, or it's estimated that we will get to deliver 20 gigawatt hours of energy cooling every year, and we will also be able to, through that cooling, get heat and then deliver 30 gigawatt hours of low temperature district heating to Brunnshög. And I can tell you now that 30 gigawatt hours of 65 degrees of district heating, that's more than enough. We don't even need that much. We will still be putting out some on the traditional network. Yeah, and in addition to that, we have the research facility ESS, which is even greater. It's an international project. ESS is still under construction, but we have prepared so that we have a pipe from our normal or traditional district heating network going all the way up here. And ESS will in the future produce about 200 gigawatt hours of energy or heat per year. Half of that will be of high temperatures, ready to be distributed in our pipe that we prepared many years ago, and half of it will be of lower temperatures. What I'm saying is that we have a lot of excess heat in Brunnshög. So with this background, let's talk about what we're building. I stated a moment ago that the problem with surplus heat is often three things: time, temperature, and localization. Localization, not a problem in this area. We're building the houses right next to the research facilities, right next to the heat source. Time is not an issue either, because the science in these facilities will be constant throughout the year. And even though we have some pauses in their activities, then we have our high temperature network, which is also inside of Max4 Energy Central, so we can just borrow some heat for a week or so if it's necessary. So we're backed up by our traditional network. And then temperature. Temperature is not a problem either, because we are preparing the network so that it works well with the low temperatures that we get. So we're building a network with a supply temperature of 65 degrees. And we're hoping to get a return temperature of 35 degrees. It's important that we get low return temperatures because it's a small network compared to our big one, and each customer affects the production really much. So we need good customers with good substations. So we think that we can get back 35 degrees or lower, actually. We will have 10 bars, which is lower pressure than in our normal network. And this whole thing will be very well adapted to low energy houses. We're keeping the temperature at 65, even though we could go lower. We've been discussing whether we should take it down even further. But keeping it at 65 degrees makes it Legionella safe. And Kerstin told you about Legionella before the break. So that's the main reason we've chosen that temperature. We also get lower production costs because our heat pumps don't need to work as hard to get 80 degrees. No, it's easier to just keep it at 65. So we get lower production costs. We also get lower heat losses in this grid. And this is where I usually lose my family. We get to distribute it in plastic pipes. Oh, you don't get it either, do you? Okay, let me tell you the awesome thing about plastic pipes. So, normal district heating, there you have pipes made out of steel. And you need steel because you need a material that can endure the constant stress of providing almost boiling water, right? You need steel. However, when you lower the temperature, you don't need steel. You can use plastic. Yeah. No, it's not awesome yet, but it's gonna be. If you use plastic, the pipes, they become bendable, right? Flexible. So, and also it's cheaper. Of course, it's cheaper. We hope so. But so the normal steel pipes, they come in sections, 15 or 20 meters, and they're pretty heavy. You need machines to lift them off and put them down in the ground. And when they're in the ground, you need space to have people welding, right? And the shaft, the cross-sectional area of the shafts, it needs to be quite wide. And this is what costs money. You need machines digging and waiting for people to be there and welding. That's where all the costs are. 75% of all the costs in a construction project is from that part. When you have plastic pipes, they don't come in sections, or they do, but the sections are 100 meters because they come on rolls. I said they're bendable, they're flexible, right? 100 meters. You don't need people welding. You can just like press them together with different techniques. And also, since you don't need so much space to be there and working, you can reduce the cross-sectional area. And this is where we save money. We save money. Yeah, thank you. Okay, so let's do it again. We're using plastic pipes. Yes. And luckily for you, we have representatives from the from the pipe company here, Logstol. You there? No? There you I have you. Please go and talk to Logstol. They know their stuff. They're developing these kinds of pipes for us. So, short about how far we've come. This is a picture of Brunshaug. So we have the most southern part. Our grid goes from there up all the way to the most northern part. That's the European spallation source. That's about 2.5 kilometers. It's quite a long area. And so we can see, you see the dark blue lines. That's our conventional district heating networks. So it comes from the center of Lund, goes up to Max 4 Energy Central, and further on to ESS. Right? I told you about that. And then we also have the, you see the green lines. That's things we've already built. That's that's steel pipes. Didn't we talk about plastic pipes? Yeah, I did. But as I said, we've been developing the plastic pipes, and we needed to start building the network 2 years ago. So we started with steel pipes. But now, last week, it's so much things happening right now. Last week, we started to use our plastic pipes. Right. How much time do I have? Not very much. Okay. So if you want to hear more about the project status, you can listen to my colleague Marcus on one of the sessions this afternoon. I've just been teasing you right now. So we have a lot of excess heat in Brunshaug. And our vision a couple of years ago was this. We thought, why don't we use this heat for ground heating when we have so much of it? We want this to be an attractive part of Lund to live in. So we spread this picture. And you know what? This picture was taken in February this year. There will be ground heating on 2 of the squares in Brunshaug and also at all the tram stations where you wait for the tram. That's pretty cool. And also, just before we did this, there was an article from Chalmers University saying that it's awesome with ground heating. So that was very nice to hear. And then finally, so this is the Swedish part that you've been hearing about, but in total, in the LTDH-project, we're doing a lot of things. We're working with, waste heat recovery. We're also investigating how we can other prosumers, like people with solar collectors or food stores with excess heat, how they can become producers in our grid. I've been looking at the business models. We're looking at the network layout and control, and we're looking at how to optimize the substations in the customers' houses. We've been doing this study on Legionella, which Justin told you about. There's a lot of things happening, and you can read all about it on coolDH.eu or on the company webpage Kraftringen.se. Thank you. No.
Thank you very much, Sara.
Tack så mycket.
Exactly on time, and a very, very interesting presentation.
Thank you.
I'm sure that we have questions from the audience. Yes, at the back.
Hi. My name is Arvid Rensfeldt, and I work for Profu, a small consultancy and research firm. And I was wondering, so ESS will supply a lot of high-temperature heat as well that you will feed into the old third-generation grid. How is that likely to affect your local electricity power production from your CHP plant in the future?
Very good question. I'm not able to answer it. No, actually, there is an answer, but you will have to go to the technical presentation this afternoon instead.
Okay.
Because it's such a long answer, I think.
Okay.
But thank you for the question.
Yeah, no problem.
No, back there.
There was another one. Back.
Yeah, hi, Jonas, also sustainability and district heating nerd. You said that the amount of local heat waste generated from Max 4, it was enough to supply the whole district of Brunshaug in the future. So I was thinking, do you have any specific plans what to do with the waste heat generated from ESS?
Well, we have a European decision to use with, first of all, energy efficiency. Second of all, using waste heat, and then third, producing actively with sustainable, and then last of all, to use energy that's non-sustainable, right? So whether we like it or not, we need to start using waste heat. And to clarify that even further, I prepared. We calculated that, well, in 2035, then you've come a long way in building the district area. We think that Brunshaug will need about 23 gigawatt hours of energy each year. That's covered completely by Max 4. And then in addition to that, we have the ESS. So we have a lot of heat. That's why we're trying out the ground heat and other applications. So please, if you have ideas of what to use this heat for, tell us.
Thank you.
Okay.
Actually, everybody went out in the break so fast that I never got to talk about the idea board. So if you have ideas that are not coming up on the workshops, please feel free to scribble away this idea.
Yes.
Can you repeat it again?
Yes, that's a very good.
Repeat the question again. If you have any.
What do you want us to do with the enormous amounts of excess heat that we have?
Please let us know later in the workshop or on the idea board.
Great. Thank you very much, Sara.
Tack Sara. Woo!
Tack.
Har du en present igen också? Hon har fått den, ja. Bra.